All right, so now we're going to talk about compound probabilities. You'll notice that in the first two examples, they have the word and in common. And our examples that follow actually imply the word and when we want both events to occur. The first two examples are using the two spinners at the far right. So I want to know what is the probability that I spin an A on the first spinner and then I spin a 2 on the second spinner. And so for this, I'm going to look at first, what is the probability that I spin an A on this first spinner? And so right there, there's my letter A, and I have a 1 out of 4 chance of spinning and landing on the letter A. And then for the letter 2, it actually shows up twice out of the 6 spots on this second spinner. And so I have a 2 out of 6 chance of spinning the number 2 on that second spinner. And for these compound probabilities, when we see the word and, we are going to multiply our two probabilities here. And so when we multiply fractions, we multiply straight across. 1 times 2 is 2, and 4 times 6 is 24. And so I have a 2 out of 24 chance of spinning an A and spinning a 2 on these two spinners. Now, for my second one, the first part is the probability of A. And so that probability didn't change. It's still a 1 out of 4. But now I want the probability of not 2. And so that's going to be all of these that are not the number 2. And so for that one, I actually have a 4 out of 6 chance of it not being the number 2. And so when I multiply these two across, I end up with 4 out of 24. Yes, you can reduce both of these, but I'm not worried about judging your ability to reduce fractions. I want you to be able to calculate these probabilities. For our next one, we are talking about marbles. So in this bag of marbles, we have 2 black marbles and we have 3 red marbles. So we have a total of 5 marbles. And we reach into the bag and we select a marble. We see what color it is. And then we do something very, very important. We put it back. We put that marble back into the bag. And then we repeat the process for the second event. So what is the probability that I get a red both times? So a red and a red. So on the first try, what is the probability on that first try that I get a red marble? Well, I have 3 red marbles out of 5 total. Now, it's super important. We replaced it. I put that red marble back. And now for my second probability, what is the chance of getting another red marble? Well, I put the first one back, and so now I still have the same probability, a 3 out of 5 chance of getting a red on the second try. And so when I multiply these two across, I end up with 9 out of 25 chance. For my last problem here, something that's super important here, I do not replace the first marble. So now I'm going to have dependent events. I still have 2 black marbles and 3 red marbles. So I reach in, I grab a marble, I keep it. I don't put it back in the bag, and then I reach in and I grab a second one. And so I'm looking again, what is the probability that I pick a red marble both times? So what is the probability of a red and a red? And so it might seem like the same problem. However, we are not reducing it. Therefore, it is a little bit different. And so the probability of getting a red on the first try is still going to be 3 out of 5. There's 3 red marbles in there out of 5 total. Now, if we look at this in terms of a picture, I've got 2 black marbles and I have 3 red marbles. And so if I don't put this marble back that I picked, now what is the probability of getting a red marble the second time? Well, that's only going to be a 2 out of 4 chance. And so my total is actually going to be 6 out of 20 for that last problem.